So good morning to all of you MSc first year physics student. So today again welcome to lecture series in quantum mechanics, and we want to continue our third chapter is angular momentum. And summary of the last lecture we have to already discuss here. What is the concept of the orbital angular momentum? What is the total angular momentum and their formulas? And in the last lecture we have here start the new point, that is the spin angular momentum. Okay, and you know that in yesterday's formula, so that see the formulas for the eigenvalue of the s square operator, sz, s plus, s minus, and so on. And using of this formula we want to represent the spin matrices. Okay, and first of all you have to know that particle with spin half and the quantum number which is ms, which is considered as the plus or minus 1. So that is if that is the s is equal to half, that is the spin half, then ms value which is considered as ms is equal to plus or minus 1 by 2. Okay, so then if we consider, okay, the particle which is can be found in the either of the following two states, so that is the eigenstate or this eigenstate of the spin, which is nothing but the s comma ms. Okay, and this eigenstate of the basis which is known as the 1 by 2 comma 1 by 2 kate vector, and another basis which is nothing but the 1 by 2 comma minus 1 by 2. So this is the eigenstate or eigenbasis of the spin operator. So we have to know that that s square operator, what is the formula of this sz operator, depends on this basis we want to calculate the eigenvalues of s square and sz. Okay, so that new point, the eigenvalues of s square and sz, okay, is given by okay. So eigenvalue formula of s square, which is nothing but the s cap operator square of s comma ms, which is given by h cross square s into s plus 1, okay, or kate vector of s comma ms. Okay, and if you put the eigenvalue is there, so we have to know that what is s is equal to 1 by 2 and ms is equal to plus or minus 1 by 2. If we doing this calculation, so that value will become here. Okay, so s cap square is of spin is nothing but the half, and ms value is plus or minus half, okay, is equal to h cross square, okay, s into s plus 1, so that is half into half plus 1, okay, of s comma ms, so that is nothing but the half comma plus or minus half. Okay, and if we doing this calculation, so that the eigenvalue of this s cap square, which is nothing but, okay, so that is the 1 by 2 plus or minus 1 by 2, which is nothing but the 1 plus 1 by 2 plus 1, that is the 3 by 2, or this is that is the 3 by 4. So this is the 3 by 4 h cross square of 1 by 2 comma plus or minus 1 by 2. Okay, so that is the eigenvalue of sz square, which is nothing but, okay, which is nothing but this s cap square 1 by 2 plus or minus, so this is the eigenbasis of this, and this is nothing but 3 by 4 h cross square 1 by 2 comma plus or minus 1 by 2. Okay, so here again we want to calculate the eigenvalue of sz cap. Okay, so sz cap is nothing but the eigenvalue formula or eigenvectors, which is nothing but the s comma ms is equal to h cross of ms of ket vector of s comma ms. Okay, again you know that this s value is nothing but half and this ms value is nothing but the plus or minus half. So that's why, so this calculation will be at here, so that is sz of half comma plus or minus half, which is nothing but the h cross or ms value, which is nothing but the plus or minus half. Okay, plus or minus half of half comma plus or minus half. We have to get separately calculate. So this value which is get sz of is nothing but the plus half plus h cross by 2 and minus h cross by 2, but we want to calculate directly in the one step. So this final value, okay, sz square value is what? This eigenvalue of sz square and eigenvalue of sz cap of half comma plus or minus half, which is nothing but this is the plus or minus h cross divided by 2 of half comma plus or minus 1 by 2. Okay, so this is the eigenvalue of sz cap. Okay, eigenvalue of sz cap. So we want to see again, once again, the graphical spin represented. Okay, or graphical representation of the spin, and this graphical representation of the spin, we have to know that for the calculation which is done by the spin taking value of the plus half. Okay, and we have to know that. So what is point? So that is the graphical representation of the spin. Graphical representation of the spin. Okay, and what is this? We have to know that idea, so that s is equal to value is considered as the plus half. Okay, and the formula of s, okay, which is given as s cross into s plus 1 s into s plus 1. Okay, and if we put this value, so that is nothing but, so this s bar is h cross, okay, under root of half into half plus 1. Okay, and this is nothing but the h cross into under root of this is half 3 by 2 into 1 by 2. Okay, this is nothing but the 1 by 2 into 3 by 2, and that is nothing but the 3 by 4. So final value of s bar, which is nothing but the under root of 3 divided by 2 of h cross. Okay, and if we see the graphical representation of this spin, which is nothing but, and how to draw, we have to know that, so that the sz cap operator, which is nothing but the vertical axis. Okay, so this is nothing but the sz cap. Okay, and the representation of this, which is nothing but, okay, so we have to know that idea, the spin value which is 2, so that is the plus half and minus half, and due to this operator, so that value of the s, which is nothing but the plus or minus h cross by 2 of sz operator. Okay, because we have to know that the sz eigenvalue, which is nothing but the, what is, plus h cross by 2 minus h cross by 2. So for example, this is 1. Okay, so this is plus h cross by 2 and this is minus h cross by 2. Okay, and so this is the EMS value of plus or minus half. So the representation of this, of the spin, which is nothing but as like this. Okay, so this is nothing but the S bar. Okay, so this vector is nothing but the spin vector, so that is the S bar. So this vector of this is known as the simply x and y. So S of x and y, the angle which is considered as the theta. Okay, and magnitude of this calculate, so this is nothing but the magnitude of the spin vector, which is nothing but under root of 3 divided by 2 of the h cross. Okay, so the vector length. Okay, so that is the this is nothing but the vector length or vector length of the spin vector, which is given by so that S bar is equal to under root of 3 divided by 2 of h cross. Okay, now so this is what S bar, and if we want to calculate the what is this angle theta, and this theta angle formula is nothing but the cos inverse of ms divided by s into s plus 1. Okay, so that theta formula, which is nothing but the cos inverse of, okay, mod of ms divided by under root of s into s plus 1. Okay, and if we solve this, so we have to know that what is the ms value, so that ms value which is nothing but the plus or minus half. Okay, and if we consider that the plus half spin, so that is nothing but the h cross by 2. So this formula, so that is the theta is equal to cos inverse of, okay, what is ms value, so this is the h cross divided by 2, and this under root of s into s plus 1 is nothing but the under root of 3 h cross divided by 2. Okay, and if we doing this calculation, this is nothing but the cos inverse of under root of 1 by root 3, cos inverse of, because of why this h cross by 2 and this h cross by 2 which is cancel, and then this formula value which is given by 1 by root 3, and this value which is nothing but the 54.73 degree. Okay, so this is given as the 54.73 degree. So this is the value of the theta for the graphical representation of the spin. Okay, so again let us now study the matrix representation of the spin, that is s is equal to plus half and s is equal to what is, and depends on this we want to see the matrix representation of s square, s z, s plus, s minus, s x, s y, etc. So that new point which is given here, so that is the matrix representation of s, matrix representation of s is equal to 1 by 2. So this matrix representation of s we will be see in the short time. So we want to see that is the matrix representation of the spin of spin s is equal to half, of spin s is equal to half. And now first we want to calculate the matrix representation of the s square. Matrix representation of the s square. Okay, so see what is the eigenvalue and eigenvector of the this s bar square, and this eigenvalue which is nothing but, so that s bar of cap square of s comma ms is nothing but the h cross square s into s plus 1 of s comma ms. Okay, so we want to calculate the matrix representation of this. So this is nothing but the s cap of square of s spin value is half. Okay, and ms value, which is nothing but, because we have to know that s is equal to half, and this ms value, which is nothing but the plus or minus 1 by 2. Okay, so that half comma plus or minus 1 by 2, and this value, which is nothing but, okay, so this half of s square, and this matrix representation or bra of half comma half. Next, eigenvalue with respect to bra of half comma half, s bar square, and this operates on the half comma minus half. Okay, again this bra vector of half comma minus half of this s bar square, which is operates on the ket of half half, and this half comma half minus half of this s bar square operator operates on the ket of half comma minus half. Okay, and if you solving this matrix representation, so how it is solved? So see here very carefully. If you understand this concept, then we have to know that how it is solving the matrix representation. Okay, so this s bar square of cap of, okay, s bar square of cap half comma plus or minus half, okay, so is equal to, so that is the matrix representation of s bar square. So this is the s square. Okay, and here the ket vector, so half half. Okay, and here also half comma minus half, so that is the eigenbasis. Or here, so that is the half comma half, and here half comma minus half. Okay, so if we want to calculate this matrix representation, we have to know that the s into s plus 1, so that is half into 3 by 2, so that is 3 by 4 h cross square. This is the value, and we have to know that half half s, and this operates on s bar square, this again half half. So for this value half half and ket half half, so this is same value s comma ms and this s comma ms, so that this value, which is nothing but the 3 by 4 h cross square. Half comma half and half comma minus half, this is not orthonormalized matrix, so that's why this value, which is nothing but the 0. Again this half comma minus half and this half comma half, because this is the orthogonal vector, so that's why this is also 0, and this is half comma minus half, this is orthonormal vector, and this is nothing but the 3 by 4 of h cross square. Okay, and for doing this calculation, so this value of s bar cap square of half comma minus or plus or minus half, which is nothing but the 3 by 4 h cross square 0 0 3 by 4 h cross square. Okay, so this is nothing but the, this is nothing but, what is the value? So this 3 by 4 h cross square, if we taken outside, so what is remaining there? So that is 1001, that is the identity matrix. So 3 by 4 h cross square taken outside this matrix, which is nothing but the 1001. half comma plus or minus half, which is nothing but the 3 by 4 h cross square of 1001. So this is the matrix representation of the s square operator, okay, or the eigenvalue, or sorry, matrix representation of the s square. Again, next point we want to see the matrix representation of the sz, okay, matrix representation of the sz. We have to know that the eigenvalue and eigenvector of this sz, which is nothing but, okay, s comma ms, is nothing but the h cross of ms of s comma ms, okay, and this is nothing but the sz cap of half comma plus or minus half, and this is nothing but the matrix representation of, okay, half comma half this sz operator, which is operates on the half comma half. Next, which is known as this bra vector of half of this sz operator, which is operates on the half comma minus half, okay. Again, this half comma minus half of sz operator, which is operates on the half comma half of the eigenbasis of the sz. And next, which is nothing but the half comma minus half, which is sz cap of operates on the half comma minus half. So we want to solve the matrix representation of this, okay. Again, see here how it is solved, this matrix representation. Okay, again see here, so that is the matrix representation of this sz cap, which is nothing but the sz cap, okay. So this is nothing but, what is the formula? So that the s cross of ms, s comma ms, s cross of ms. So we have to know that the sz value, okay. So if taken first of all half of half and this half comma half, so this h cross value is nothing but the plus h cross by 2. So that's why this is nothing but the h cross by 2, okay. So this is nothing but the h cross by 2. Again, this half and this value is 0, this is also 0, and this is minus h cross by 2, because the spin value ms value, which is nothing but the minus half, okay. So again see that, so this sz cap of s comma ms, which is nothing but the, okay, so this matrix value is h cross square by 2, 0, 0, minus h cross square by 2, okay. And again solve this, so this is nothing but the h cross square by 2, sorry, not h cross square, only h cross by 2. So this h cross by 2 taken outside, so in between matrix 0, 1, 0, 0, minus 1. So this is the matrix representation of the sz cap, okay. So in this lecture we have to see here the matrix representation of the s bar square and sz. Next lecture we want to calculate the matrix representation, or show the matrix representation of s plus, s minus, sx, sy cap. So this matrix representation see, and after that we want to calculate the eigenvalue of the L square and Lz by spherical method, okay. So thanking of you.